Dear colleagues, my name is Mutowkina. I am an Associate Professor of Accounting and Finance at Tiba State Technical University. Your attention is inviting to the report on the topic, Fuzzy Assessment of the Sustainability of the Agricultural Engineering Industry. Agricultural engineering is a support for the development of agriculture. The level of development of agriculture machinery depends on the demand for this technique. A raising in the intensity of agricultural production, an increase in the number of its producers, and an increase in their work efficiency are the main factors for improving demand for farm products. An increase in demand for agricultural products leads to a rise in demand for agricultural machinery. The complex fuzzy assessment allows to determine the level of stability of the farm engineering industry according to heterogeneous criteria and make management decisions in the conditions of missing information. The third slide briefly presents the current state of agricultural engineering in Russia. As can be seen from the graphs, the production index in the industry, although increasing, is still less than 100%. The dynamics of production of the main types of agricultural machinery are abrupt and unstable. Agricultural machinery is characterizing by a high percentage of wear and tear. In the farm sector, there is a need for urgent renewal of fixed production assets. However, this is all official data obtained from open sources, official statistics sites. To fully assess the level of sustainability of the development of the agricultural engineering industry, a whole system of indicators and characteristics of the state of the industry is required. It is also necessary to take into account the specifics of the industry. On the fourth slide, the features of the evaluated industry are considering enterprises that specialize in the production of agricultural machinery and equipment for mechanizing all types of agricultural output, tillage, sowing, harvesting, are the basic units of agricultural engineering. Thus, one of the essential conditions for ensuring food security at all economic levels, international, federal, regional, local, municipal, is the development of this branch of engineering. The problem is to determine the level of sustainability of the development of the agricultural engineering industry, which is a kind of indicator of decision making on measures to support the initiative. According to the level of sustainability of the industry, decisions are made on the participation of the state in co-financing, subsidizing, etc. The export opportunities of the sector are evaluating. The leading enterprises and outsiders of the industry are identifying. The fifth slide shows the formulation of the research goal. The purpose of the study is to form a methodology for a fuzzy integrated assessment of the sustainability of the development of the agricultural engineering industry. The estimates obtained using this methodology are the basis for making a set of measures to create conditions for improving the state and increasing the sustainability of the industry's development. The sixth slide shows the methodology used in this study. In itself, the concept of sustainability is somewhat vague. The degree of stability for each individual is different. It usually has boundaries, in which it can be considered non-sustainable development, below average sustainability, conditionally sustainable development, sustainable development. At the same time, the borders themselves are also blurring, individual. When considering a complex system, it is possible to judge how steadily it develops only based on data on its state for a certain representative period. As a rule, a gradually increasing trend in key indicators indicates sustainable growth. An intermittent tendency shows unstable development, a decreasing trend signals destruction, and a constant level indicates stagnation of the system. However, Such data is often difficult to collect or not available. Such situations arise if there is a trade secret or the system was forming recently and data on its state, results of work are not yet absent, or they are not enough to identify a trend. In these cases, it is advisable to conduct an assessment by comparing the values of indicators with the industry average values, average and relative values for the region, country, and the world. You can also attract experts who can adjust the comparison results of comparison into account for weighting factors. Weights characterize the impact of the system and its subsystems on other schemes. The significance of the system and the results of its work for the population and the economy as a whole, the sufficiency of the development for the local economy, etc. The seventh slide provides a brief overview of existing assessment methods. Of course, there are many more such methods, but they all mainly involve considering critical indicators of the state in dynamics. Considering this fact and the presence of many heterogeneous characteristics of the evaluated industry, the author proposes an assessment methodology based on elements of fuzzy logic and expert assessments. Fuzzy multiple modifications have broader opportunities to record the uncertainty of external conditions and expert evaluations, greater compactness, clarity, and ease of use in contrast to precise data mining methods. Among the most primary elements of fuzzy logic, we should single out the concept of a linguistic variable, the values of which are words or sentences in a natural or formal language. A linguistic variable roughly describes complex phenomena and processes that cannot define by precise quantitative characteristics. And fuzzy sets play the same role in determining this variable as words or sentences in natural language. The eighth slide shows three groups of evaluation characteristics: economic, social, and technological. The most important indicators were selected by experts in each group. Slide 9. The following economic indicators attributed to the first group: the number of enterprises, the production index, the investment in fixed assets, the share of profitable organizations, the profitability of products, the return on assets, the percentage of repaid debt on the obligations of enterprises, the share of repaid receivables. Social indicators include the difference between the number of employed and moved to another job, the average accrued salary for the month, the number of tractors per 1,000 hectares of arable land, the load of arable land per one tractor, the average number of accidents per 1,000 employees per year. Among the technological indicators, the following were highlighted: the degree of validity of machinery and equipment, the degree of suitability of vehicles, the proportion of fully updated machinery and equipment, the balance of fully updated cars, the level of use of the average annual production capacity of enterprises. Next, the indicators are ranking by importance. The 10th slide. The ranking is basing on equality. For evaluation, it is recommending to use from 4 to 10 indicators in each group. The number of indicators less than 4 will not give a sufficiently informative assessment, and exceeding their number will lead to unnecessary complications of the evaluation model. After that, the acceptable and target values of the stability indicators are determining by experts. The 11th slide. The target values are desirable and ensure maximum sustainability of the industry. This is necessary to further define the membership functions for each indicator. Also, the following linguistic variables are introducing. The next stage of the methodology is to set the membership functions. The 12th slide. Each sustainability indicator has its membership function defined. The choice of membership functions is primarily influencing by the nature of the stability indicator. If an increase in the parameter values indicates an increase in the sustainability of development, then the membership function has the second form. If an increase in the indicator's values suggests a decrease in the sustainability of growth, then the membership function has the third form. The 13th slide shows the calculation of the overall stability assessment. In practice, the ideal variant, when all the indicators are sustainable, is usually not implementing. Sustainability of development can characterize by parameters whose values are near the sustainability area. Therefore, we can talk about some scale of sustainability of growth. This scale is just demonstrating on the 14th slide. The table shows 4 possible states of the linguistic variable comprehensive assessment of the sustainability of the industry development. Such conditions are uneven development, stability below average, conditionally stability, and sustainable development. The 15th slide presents the initial data for evaluation. Acceptable and target values. The initial data for experimental calculations were taken from official sources of statistical information. The level of development of agricultural engineering in 2 regions of the Russian Federation and Russia was assessed. Experts set acceptable and target values of indicators. The importance of the membership functions calculates using formulas 2, 3. If the weights in the groups are equal, the estimates for the groups of indicators computed using formula 5 are presenting on the 16th slide. The complex assessment of the sustainability of agricultural engineering development is determining by the formula 4. The weight coefficients in the procedure were set as 0.4, 0.3, and 0.3. Respectively. Thus, the first region is characterizing by the uneven development of the agricultural engineering industry, and in the second region and the country as a whole, stability is below average. For each state of the resulting variable, recommendations and measures aimed at improving the sustainability of the agricultural engineering industry were determining. The corresponding table is shown on the 17th slide. Based on the evaluation results in the considered example, a plan should be forming from the activities of the first and second groups. So, the recommendations of the first group include improvement of the personnel training system for the agricultural engineering industry, strengthening the financing of the industry through state subsidies, diversification of production at the main suppliers, dealers of large Russian manufacturers of agricultural machinery, development and implementation of innovations in the industry to improve the quality of equipment on the 18th slide. The results of the proposed assessment methodology are summarizing, its main advantages are considering. Thus, the developed method has shown its applicability for assessing and ranking the sustainability of agricultural engineering in the regions of the Russian Federation using multiple fuzzy aggregations of normalized assessments of the sustainability of its 3 subsystems: economic, social, and technological. The suggested method has such advantages over existing analogues as universality, taking into account the weight coefficients of indicators and their variability, and the ability to consider the opinions of experts. Moreover, to implement the methodology, specialized software can be developing that allows determining the sustainability of the promotion of any other branch of the economy. Thanks for your attention.